This nitric oxide is responsible to activate the guanyl enzyme guanyl cyclase. This guanyl cyclase is responsible for the conversion of GTP into cyclic GMP. Likewise, adenyl cyclase is responsible to convert ATP into the cyclic AMP. Similarly, this guanyl cyclase is responsible to convert GTP into cyclic GMP. And this activation of this enzyme is done by the nitric oxide. This cyclic GMP, along with the myosin light chain kinase phosphate, together they are responsible for the relaxation. So, what is the function of cyclic GMP? Is to convert myosin light chain kinase phosphate into the myosin light chain. So, it causes the dephosphorylation. So, generally, cyclic GMP is responsible to activate the enzyme protein kinase, and this kinase enzyme is responsible for the phosphorylation or dephosphorylation. So, generally, this kinase enzyme is dephosphorylate this myosin light chain kinase phosphate into the myosin light chain, and this myosin light chain is responsible for the relaxation of the vessels. Okay, if cyclic GMP is not there, then myosin light chain kinase phosphate is formed. It is along with the acting, it causes the contraction. So when we are giving the nitric oxide, this nitric oxide first activates the guanyl cyclase. So this activated guanyl cyclase convert GTP into the cyclic GMP, and this cyclic GMP activates the enzyme kinase, and this kinase causes the dephosphorylation of myosin light chain kinase phosphate into the myosin light chain. So the phosphate group removal takes place, that is the dephosphorylation takes place, and this myosin light chain is responsible for the relaxation of vessels. If this kinase enzyme is not available, then myosin light chain kinase phosphate is formed, so it causes the contraction. So activation of the cyclic GMP through nitric oxide of the drugs, they are responsible for the dephosphorylation of myosin light chain kinase phosphate into the myosin light chain, which is responsible for the relaxation. So the blood vessel relax, blood vessels जर relax झाले तर diameter त्यांचा वाढतो, diameter वाढला, more amount of blood can be flow through the vessels, and more amount of oxygen and blood can be supplied to the heart. Now suppose this is the vessels, there is a deposition takes place. Okay, so less amount of blood can flow this through this less amount of blood can be flow. But when nitric oxide causes the vasodilation, what happens? The diameter increases. So this distance between these two walls increases, and due to that increase in internal diameter, what happens? If there is atherosclerosis also, due to the increase the distance, more amount of blood can be flowed through the vessels, and when more amount of blood can flow through the vessels, more amount of blood can be supplied to the heart, that is the more amount of oxygen supply takes place to the heart. So that is the mechanism of action of nitrate and its derivatives. Okay, so this is given in the format again: nitric oxide. This nitric oxide, it activates guanyl cyclase. Guanyl cyclase activates conversion of GTP into cyclic GMP, which activates the enzyme protein kinase, which causes the dephosphorylation, and this myosin light chain is responsible for the relaxation of blood vessels. The nitrate derivatives are used for all kinds of angina pectoris. In heart failure also they can be used. These are the examples: glyceryl trinitrate or nitroglycerin, amyl nitrate, isobamine nitrate, erythryl tetranitrate, pentaerythrol tetranitrate. So these are the useful antianginal drugs which releases nitric oxide, which causes the vasodilation. So which are short acting? So these three are short acting, and these are the long acting nitrate derivatives.